Mel Science Homeschooling Educational Science Experiment, the heat transfer box, step-by-step instructions. Oh, yeah. The molecules in these pipes start to vibrate. It is frozen to the box. That is so neat. Mel Science Heat Transfer Kit. Go check out their website. Hi there. Welcome back to my subscription box life. I have a new box for us today. It's called Mel Science. And as the name implies, it is a science subscription. And I've gone to the Mel Science website and they have a lot of experiments for all age groups. This is a great subscription or website for homeschooling parents that want to add to their science curriculum. They even have coding. So if you have a student interested in that, they have coding boxes as well. But I'm going to put a link to Mel Science down in the details of this video. Right now, they have a really awesome discount for subscriptions. So if you're interested, go there, click the link. It will pop up, the discount will pop up right at the top of the screen. So go check it out. So I got a subscription to Mel Science, and within my first box, this is what I received. This box is filled with smaller boxes, and each one of these boxes contains an educational science experiment. When you subscribe, you can go in and choose which kind of science you want in your box and age groups and that kind of thing. I chose a mixture so that I could show you. The first experiment we're going to do, and I'm going to, because I received so many experiments in this one box, I'm going to start a Mel Science series. And so we will go through these boxes one by one and do each one of these experiments together. So the first one I chose is the heat transfer box. And let me show it to you. So in here, they put a QR code. You can scan this code. Mel Science has an app that you can use, and you can find the heat transfer box right there. And on the app, it will give you step-by-step instructions, and there's pictures that go along with the instructions. And they also have a feature where you can take a picture at different steps and send it to them, and they will let you know if you're on the right track and doing the right thing with your experiment, which I think is a really cool interactive feature. But not only do they have this app, they also have this handy dandy little instruction booklet in here. And I went through this booklet already, and everything in here is written very clearly. And I actually only needed, I looked at what was behind this QR code. It is very, very, very helpful. But if you didn't want to use the QR code, this little booklet here is plenty detailed instructions, and it does have pictures that go along with it as well. It makes the experiment very, very easy. I was able to follow it very easily. But this is what it looks like inside your box. It has different labeled for your different experiments. Because I was going through this, I got them in the wrong order. But there's 3 experiments listed in this book to do with the items in here. However, if you scan this QR code, it gives you a bonus experiment. So everything you need to do all of the experiments, all of your heat transfer experiments, Mel Science has given you everything. I am going to get our this little area set up for us, and we are going to do the heat transfer experiment together right now. Stick around. Don't go anywhere. All right, let's get into these experiments. So our first experiment is going to be a heat trace experiment. Let's get our little envelope number 1 out, and we need our straw. So this experiment, this uses a thermochromic screen, which is it's really cool. You can see the heat transfer from whatever item it is that you lay on here. So we're first going to try our hand on it. And I'm keeping it in this bag right now because this film, the screen is so sensitive that just even a little bit of touch will change the color. And the colors vary by the hottest area to the coolest area. So the bluer area will be the warmer area, and the yellow, orange, and red areas will be the cooler areas. So let's try this with our hand to start out with. And it says to put it on for 25 seconds, but even if I just tap it lightly, it makes, you can see just a faint hint of my finger anywhere you touch. See, I've held it. You can see just a faint little bit from where I've touched. So let's do what it says to do and put our hand on it for 25 seconds. All right, let's take a look. So my hands must be a little bit cold today because we're getting the very light colors showing up for my hand. I am going to go run my hands under some hot water, and we'll see if it changes anything. All right, so I just did a heat transfer. I put hot water onto cold hands, so I transferred the heat from the hot water to my cold hands. And now let's see what it does. I noticed that when I just put my other hand under it, you can see that it's changing colors. So I think it worked. It's already going away. All right, I didn't count 25 seconds this time, but let's see. Oh yeah, that's nice. You can really see the blues, the greens, the yellows, the oranges, the reds in there this time. And look, even where my 2 thumbs are holding, my hands are so hot it's turning those little areas blue. Make a little pattern around, and you can see it cooling down. It's going green. It's going yellow, orange. And then you might be able to see a little bit of red at the end. Let's see what happens when I blow on it. See it, my kids think I'm full of hot air, so let's see if I actually am. Maybe I am full of hot air. Do one more time, just a really nice, deep, long breath. The second heat transfer experiment we are going to do is called evaporative cooling. So let's get all of our tools out of our box. We are going to need our thermochromic screen for this one. We are going to need the straw, our envelope number 2 with our tools in it, and this little basin, this little square shaped basin. Evaporative cooling. Take water as an example, boiling water. You have your water molecules in the pot, and as the water molecules begin to get hot, they begin to move and vibrate. And the vibration causes them to become even hotter. So think of my hands as water molecules. When they're just sitting here like this, they're cool. You're not feeling any heat on your hands. But when you start to rub your hands together and vibrate your hands together and move them, you actually start to feel heat because of the friction between your hands. That's what's happening with your water molecules. Water molecules are bonded. So what happens is when you think of anything that's moving around that's tied together, it will break. So the water molecules break apart and they float off into the air as a water vapor, or they become gas. If you've ever been to Florida in the summer, you have felt the humidity in the air. That's the water vapor in the air. So let's take some freshly boiled water here, and we are going to be very, very careful with your water. We're going to take our little spongy piece here and put it in the water very, very carefully with our tweezers that they gave us, that Mel Science gave us. Pick it out, and we're going to put it in the little basin, and we're going to detect any water vapor coming off of this with our thermochromic screen. So let's put that on there. There it goes. You can see the water vapor coming up and warming the screen up. Now the little tube of sponge that I put in there is in this direction, and you can actually see it as the water vapor came up in that position. So it's now the water vapor's filling the basin, and it's creating this square shape on the screen here. So the fast moving molecules of water come off and become water vapor. The slower moving molecules of water will remain as liquid water. It looks like it's cooling very slowly now. The little square is getting smaller. The green is filling in. The blue is going away. The blue is the hottest area. You have the green, the little violet, the green, the yellow, the oranges, and the red around the very, very edge. So very slowly, it's cooling. Oop. Well, that didn't help. And now there is just the faintest little mark on the screen here. So I'm going to take it off. I'm very curious to see if there's any water vapor on here. There is water vapor on here. You can see it right there. So we've collected some of the gaseous water molecules onto here, and it's actually formed another little layer of liquid water. Very neat. Okay, I bet this is cool enough now that I can touch it with my fingers too. I feel comfortable because the thermochromic screen cooled down so much. So yes, it is cool. So and it is still wet, so our coldest water molecules are still attached here. The hottest, clearly some of them attached here and remade some moisture. So very neat. Okay, now I'm still have this boiling water. So I'm going to put the water on top of the screen now. Put little dots on. See what happens. Right, our water is still hot. So our bigger ones here, you can see they're holding the heat longer than the smaller ones down here. These are already losing their color. So this water is cooling very fast. One of our biggest still has a little bit of color. All right, I'm going to wipe this dry. This time I'm going to make one big dot of water in the center. See what happens. I'm going to try to make one big dot. Right there. You can see the edges get cool faster than the center because it's deeper in the center. So the outer edges are colder than the center. Now I'm going to blow on it and see what happens. It cools quicker because it's thinner water. But now we have I moved a lot of the water over here. Let's see what happens again. Blew it off the edge. And it's back to the original color. Well, that was a fun evaporation experiment. All right, I've filled my bag with water. This is going to be our hot source, our heat source, and they've given us little stickers to put on here so we know that it's hot. The one that's missing is the one that is on the bag that I put in the freezer and created ice. So I'm going to put the little hot symbol on. I'm not sure how well this is going to stay because I've boiled some water here. And I'm going to put this bag in the water to heat it up, get it good and warm. Be very careful, caution. That is very, very hot water. And now I'm going to put this together. The little cardboard tray came with this wooden divider. So you just snap it on and it holds your rods in place, but it also gives a bit of a barrier for your heat source and cold source here. And then right on top of that, we're going to put our thermochromic film so that we can visualize the heat transferring down the rods. Now you can make a little prediction, just make a prediction in your mind, which is going to conduct the heat faster? Is it going to be the copper or the aluminum? Or are they going to conduct the heat at the same time? Heat conduction is basically how fast something heats up. Something that doesn't heat up very fast is a low conductor of heat, and something that heats up very fast is a high conductor of heat. Okay, let's see if I have this warm enough to transfer heat. And as we can see, one is already outpacing the other. So this is the copper side and this is the aluminum side. And clearly the copper transfers heat faster. You're seeing a little dip here because the screen is not touching the copper as well there. So what happens is at the heat source, the molecules in these pipes start to vibrate, and it sets off a chain reaction all the way down. So these at this end where the heat sources started to vibrate, it caused a chain reaction and caused all of the molecules down. You can see it really well with the aluminum, how it's hotter here and cooler here, but as it heats, it continues to get warmer down at the end. So it's causing a chain reaction from the vibration of the molecules. So these are starting to move faster. The molecules in the aluminum are starting to move faster down here. As you can see, it's getting wider, meaning it's getting hotter, meaning the molecules of the aluminum are moving faster. You can also see in our copper how hot that's getting. It's getting wider. As you notice, this is all about almost the same width. So this pipe is becoming the same temperature all the way down. The aluminum is slowly becoming the same temperature all the way down. So the copper is a better conductor of heat than the aluminum. Now let's try the ice. So I have the ice here. The directions say to take the ice out of the bag, but I went ahead and just made this ice and molded it to the rods here so that I can just set it right on top. So now the heat will transfer back to the cold ice. So let's see what happens when we put the ice on. Heat always transfers to the cold. We'll see if some of this ice even starts to melt. See which one is cooling the fastest, which one is transferring the heat to the cold faster. It appears that the copper piping, once again, is transferring the heat faster. So the insulation in our house is a poor conductor of heat, and that's why we put it in our walls, so it keeps the heat out or the heat in the house, or just the opposite, the air conditioning in the house and the heat out of the house. And then copper is actually used to cool items. As you can see, it cools very quickly, so it transfers the heat away and cools whatever is inside of it. That was an excellent visualization of thermal conductivity. This Mel Science Heat Transfer Kit has 4 experiments in it. The 4th one you find on the app that you can get by scanning the QR code. And the items are included in your kit. You're actually going to use the box for this part of the experiment, but let me put it off to the side real quick. This is going to be a salt freeze experiment. And so here's the bag. And we have been given a pipette and a little petri dish and the bonus experiment directions right here. And it's basically just saying to scan the QR code and find the instructions. So let me show you what that looks like. I've scanned the code and up pops a step-by-step guide to this bonus experiment. And to go through the steps, you just swipe, and it's very clear with the pictures. And once again, this app makes your experiments very easy to do. So I'm going to unwrap this box. And there's a surprise under this cover here. We have the Mel Science dots. Now we need to take water, and I just have some tap water here. And it's asking us to put 30 drops of water on here. So my table is a little crooked, so I'm hoping that the water stays on. I think I put a little more on than 30 drops, so hopefully that is okay. Now for the next part, they said you can use this little basin that they had given us to put ice in. I am just going to use some ice out of my freezer instead and see how that works. So I have some ice for my freezer. I'm going to set that aside for the moment. And I'm going to set my petri dish on top of this water. I am going to put a teaspoon of salt into my dish. And now I'm going to set my ice on top. Ice freezes at 0 degrees Celsius. Now my freezer is colder than 0 degrees Celsius. So this ice that has come out of my freezer is actually colder than the freezing point of ice. So now it is melting. Now it's making salt water in here. The freezing temperature of salt water is also below the freezing temperature for plain water. So what we should see happen is the water, the plain water that's underneath, should be transferring its heat to the salt water and in turn becoming so cold that it turns to ice. So let's see if that works. Mel Science gives us a timer. So it's counting down. Okay, our 2 minutes is up. Let's see if this is frozen to the box. So we're supposed to try to lift it up, and sure enough, it is frozen to the box. So our salt water absorbed the heat from the regular water. The regular water from the tap turned to ice, and now our petri dish is frozen to the box. That is so cool. What an Another interesting example of heat transfer. That is fantastic. I've taken the petri dish off and you can feel the ice in here. So I can actually move the ice around on top of this box now. It's slowly melting. That is so neat. This Mel Science Heat Transfer Kit is a fantastic hands-on and visual learning experience, not just for homeschooling students, but for any curious kid or adult who enjoys working with their hands and having fun while doing it. For those of you that don't know, I have a Master's of Science degree, and I have done my plenty fair share of science experiments to learn. And Mel Science has put this kit together fantastically, in my opinion. It starts out with just a simple example of heat transfer, and then each experiment builds upon that to get deeper into the physics concept of heat transfer. In addition to that, I love the way Mel Science has provided the step-by-step instructions, which I think is fantastic. So this is the Mel Science Heat Transfer Kit. It's for ages 8 and above, and it's a physics concept. I am going to put the link to Mel Science down in the details of this video. Click on it and you can go check out their website. They have all kinds of experiments for all kinds of ages there. I'm also going to put the pictures from this experiment on the blog, mysubscriptionboxlife.com. Go check it out, see what's in this kit, see some pictures of the experiments that we did together. In the meantime, don't go anywhere. I'm glad that you joined me. I have another box coming up for you.